Says connected. Is it working? Let's see. Excellent connection, but I'm not seeing anything. Oh, there it is. Yes, it's working. Great. Is there audio? Test 1, 2, test, test 1. The audio is a little hot. Check 1, 2. Check 1, 2. Check 1, 2. There it is. I think it's better now. There we go. Good day, everyone. It's a little spontaneous, but I'm here, and welcome to essentially my lab space, which I will be spending more time. And it seems like a suitable environment for videos. This is what's been taking much of my time here, moving everything around. I'm almost ready to go. Few things here. I'm trying to set up this computer here. I haven't started it up yet, but with my luck, every time I move a computer around, it never starts back up. So it's never plug and play like it should be, right? So I'm gonna cross my fingers, and tonight, hopefully, I'll be able to start that up and get it working on that screen. Because down the line, what I want to do is I want this to be my spectrum analyzer, because I'm gonna run this hack RF on there. And it's been a while with this software defined radio as well, so I'm gonna have to do some driver hunting and find a program that's compatible with it, because I want to use this to scan for frequencies in the RF range. It's USB. I I remember using it in Linux a lot with GNU Radio. They had scripts ready to go for it. Not that great of a tool for transmitting. Oh yes, SDR Angel, I believe, does it. Yeah, I guess I could use SDR Angel, but it's more for transmitting. We'll see. I'm not there yet. Um, so yeah, just randomly saying hello to everyone, and yeah, like I said, I'm almost done here. I'm gonna try. I'm just dreading oversetting this computer up. First thing first, I guess if the screen works, can I get this to turn on? Maybe I'll need a power bar. Try a power bar because I don't know if that plug works. So as I suspected right from the start, screen won't even turn on. Ugh. So I'm gonna put a power bar here. Got a UPS down here. I know that works because that's what the computer is connected to. So no big plans tonight, by the way, just showing everyone what I've been up to, and there's still some work to do tonight. I figure a couple more hours, but people sometimes like seeing the background of everything, what I do. And so this is a way, I guess, to get to know me from behind. um, yeah, let's see now. Hopefully this works. This power bar is lighting up, so that works. That's a good sign. Get that screen to turn on now. Oh, I see a light. Uh, Technology. Oh, okay. Source. Maybe this is dead. Oh, Source. It's not detecting the H. Okay, maybe I should turn the computer on first. Okay. Where's the source? So what am I doing wrong? Oh, what did I do? I didn't do anything. Yeah, I know, folks. I'm so sorry. I'm just being stupid here with technology. How do I get this thing to HDMI? My goodness, smart, all right. This makes everything more complicated. Come on. No, I want to go to source. So there's one button here. Where's the select? Hold for select. Not available. Oh, maybe it would help if I plug it in. Oh my goodness. Oh, PC, yes. Switch. Why is it taking so long to load? Oh, the computer's still turning on, I see. Maybe this thing is gonna go away after a while. Maybe the mouse is dead. Anyways, while this loads, just a general hello to everyone. Looks like the computer's loading, but maybe my mouse needs a new battery. So I'm going to look. Now the thing about setting everything up is you don't remember where you put everything. It's so organized now I can't find anything. It's so frustrating. I don't know if that's ever happened to any of you folks, but sometimes I hate being too organized. Then it's like, where's everything? There are labels, but then I have to read everything. Oh, maybe that's in the other room. I'm gonna have to fix this, folks. Billy battery that never wears out. End of the story. Plus and minus. That's what it was. Okay, that's a good sign. All right. That's working. So yeah, that's a good sign. Now I gotta figure out. I don't know if I already installed this or not. Guess I'll find out soon enough. Let's see. I'll find out real quick if it's in the system or not. Uh, Device manager. So what do we have? Sometimes it shows up here. Yeah, I guess I'm gonna have to. It's not detecting. All right, so let's go online. This mouse is a little touchy here. Looking for RF Windows. There was a few of them, but I forgot which one is best. So I have, it says internet access, but nothing's loading here. Oh, I know there's internet because I'm live here. The wonders of always, I'm telling you folks, every time I move a computer, there's always issues, and there should be. You're just turning it on, off, and putting it on. All of a sudden, it's like it's on a new planet. Looking for adapter options. Man, this mouse is really fidgety. There we are. It says internet. It's the right DNS. Yeah, everything is fine. That's odd. OCMD. Ping Google. So getting a reply from Google, so why is Chrome being, oh, there it is. HackerRef. Which one was it? I totally forgot which software I used. Or was it SDR Sharp? SDR Sharp. HackerRF1 on Windows with SDR Sharp. That's it, I guess. that's it. There it is. That's what I got. My goodness, about $320, that expensive? Oh, but I want, looking specifically for the Windows. Right here, for Windows, that's it. Site's down. Someone will have it. So YouTube, I don't want YouTube. I'm looking for the SDR Shark with the plugins. I should have backed this up a while ago while I could. So once I can get this going, I could be able to proceed with my next project. SDR Play. So SDR Play, that works too. So still SDR Sharp. So with SDR Angel seems to be, so I'll try SDR Angel, I guess. I didn't like it because it seemed overly complicated, but I'll try it. Then I need Windows. Oh, get this, folks. It's just pretty important. I need to have a spectrum analyzer working. So yeah, got some ideas here. I did the before I got all involved in all these minor changes. I was working on the Maxwell equations, and there was some pretty interesting revelations in there and new interactions. And it was hinting at using, I've explained it in the previous videos, higher frequency the better it is. So I wanted to experiment in the higher RF frequencies, much higher, more so than most people experiment with. So with that, I had the Hack RF and a few SDR units that worked very well for that back when I was into ham radio. And I haven't really had much of a use for it since then because, as I said before, most of my ham local ones, anyways, unfortunately, they've all passed away. So that pretty well ended that run. And I still have ham radio friends, by the way. It's just they're scattered much further away. You know, when they're 6, 7 hours away, it's not like you can get together and, build a module or something that easily. So that pretty well ended that hobby for me. But as I said, it was the learning experience for the interaction of the radio and tuning the resonance and primitive LC tank circuits and that sort of thing. I was always fascinated with the spark transmitters and that sort of thing, crystal radios. So I was never one that was too thrilled with actually making conversation on ham radio. Even when I was a teenager, it was like we have cell phones for that, right? But it was the whole technical background behind it, calculating propagation of radio waves and that sort of thing, and how, they interact with different materials and what's the difference between linear polarization versus a nonlinear polarization and the benefits. A lot of Tesla stuff, actually, indirectly, but a lot of fun, a lot of learning I did from that. So I got a lot of leftovers from the ham radio times and the knowledge of that, right? So when I was a teenager, it was still a pretty intensive test. The study book and everything was, they really dug deep into basically Ohm's law and that sort of thing. And ironically, most ham operators don't use that. They just, rush through the study material just so they can talk on the radios, and they buy the pre-made stuff, and there's no more of that basically homebrew do it yourself, especially when it's a lot easier to buy a radio pre-made, right, for less than $100. So a big part of the art got lost anyways near the end, especially when you got into the 80s. There was no real other from educating yourself if you were into that of building your own gear, right? So there was still a few old timers that knew what they were doing, which were really nice to talk to at the time. And that was about that. Now let's see if my downloads are done here. And we'll see if I can at least get this SDR thing to detect. This is the environment. I don't think it's actually. SDR Angel is the other one. But I want SDR Sharp. SDR Sharp. Download. HackRF driver right here. Perfect. SDR Sharp it is. Now it's asking for a runtime environment. Oh, somebody is here. Hello, everyone. The sound volume up where you had it when you started, we can hear. Oh, it looked like it's blaring here. I'm sorry. It's weird. I will turn that up definitely. There we go. Check 1 2. That must be better. I was in the red there and I said, oh my goodness. So yeah, as I was saying, I was getting my new space ready for my lab. Almost done, just was trying to get the computer going here, and I was just complaining about every time I move a computer, it never starts back the way it should. Always unexpected issues. So seem to be doing pretty good here, and I'm trying to install my HackRF. I want to use it as a spectrum analyzer for some of my high frequency experiments, ranges that are way way out of any scopes I have here. So that's going to work for that, hopefully. And I'll be able to proceed with my experiments as I was. There was some new interactions with the Maxwell equations I wanted to experiment with, which gave me some hints on what directions to go. So that's what I'm doing here. And hopefully I can install the program. But now it's asking for Net Framework. There's always a new version of Net Framework, it seems. Oh, and it's giving me the x86 version. Is that going to conflict with my 64? This is the wonders. Oh, so far so good. Let's go to configuration. Source, I'm looking for HackRF. And the audio. How about that? It's working. I don't know if you guys could see that. I'm going to try and bring the monitor up a little bit. There we go. So now, there's no antenna on here, so it's not going to be very powerful. So what I'm looking for, wideband FM. Must be some configurations here because I knew there was a gain. Oh, here it is. Let's see if I can. So this is FM here. They're just decoding the RDS and everything. And over here's there's the spectrum. And there's the frequency trace. The spectrograph, essentially. And yeah, so that's great. That's working. So let's see if I can. I've got a station on 104.7. I don't think they'll pick it up from here. Tower's about a mile away. I'm gonna have to show you guys that one of these days. Go for a tour. Tower's about 100 feet high. I don't get it. This has basically no amps, so but I do get it on here. There's 104.7. So that's 104.7 from uptown, about a mile away. But my hack RF, the signal's too weak. It's just 1 watt. So it doesn't penetrate too well when you just got a spectrum analyzer, unless there's an amp on there like a regular tuner. But this 102.7 here, they're just down the road here. It's a church. So I'm literally a block away. So that's why it's coming in at like minus 57 dB. So that's going to work, folks. I'm really happy. I'm I'm really happy about it. Let's see here. See, I don't know anymore. Some people are saying the sound is good, some people are saying it's not. Like on my end here, when I talk, it's saying, yeah, I'm peaking at 0 dB, so it might be clipping a little here. Check 1 2, check 1 2. Check, check, check. See, right now I'm right before 0, so it shouldn't be clipping. Sound is good. Okay, that's good. So now I'll be able to proceed. I'm going to shut that off because there's no use listening to static here. So, I want to experiment with higher frequencies. Tesla's work, basically, what we were doing, canceling fields and scalar waves, harmonics, resonance. But the new Maxwell equations, when you do a deep dive into them that I have on a video here, it hints basically I was saying this earlier, what it does is the 0 point interactions are very brief. And according to the calculations, if you were to make like take an average, it would be 0. But that's just the average. There's in between very sharp, very high concentrations of energy during those 0 point interactions. They're brief. And I've explained why when I drew the waveform in some previous videos. All in details if you're all interested in that. But yeah, essentially, with the help of the Maxwell revelations, higher the frequency, the better it is. So I'm thinking actually microwave frequencies now, because easier to confine, we can use waveguide technology, so we're not limited with big heavy wires and having to deal with all that high frequency leakage and spurious. Microwaves are a lot easier to refine. It's almost like a laser beam, and you can build waveguides. So essentially, the equivalent of a resonant cavity on microwave would simulate the same effects of a big Tesla coil, but for the size of the tip of my finger. So this opens up the avenues for, exactly what Tesla was doing with multiple resonators where one feedbacks into the other, well, not into the other, but how it creates more noise as one in the same room like Tesla was doing, right? But at microwaves, you could expect that what happens is that the microwave gigahertz frequencies, the RF energy is a lot more dense in relative to regular RF. So there's a lot of energy in there, folks. So if you can get like Tesla coil equivalent of microwave resonators, that will create its own energy field. And it'll be a much denser energy field in relative to the size. So back to efficiency, it may lead to a much more controlled, easier way to tap into these Tesla systems. But with today's technology, Tesla didn't have 2 gigahertz systems to play with right off the bat. We do. So with that said, I found an old microwave. Seems to no, brand new, actually, it seems. People were cleaning out the storage room, so I took it. And I want to experiment with the magnetron. And I want to dry cold reactions are very interesting because the microwave magnetron shares a lot of similarities with the old style vacuum tubes. It's an electron thing. And at certain high voltages, you can what you call a cold cathode reaction. It's a cold reaction. And it's highly nonlinear, which fits into what we're experimenting with. You want to have nonlinearity. And the calculations, support that as well. and resonant conditions at microwave instead. So what I'm getting at is I want to start experimenting with the magnetron, feeding it basically zero current at different high frequencies, electrostatic even. And you already got the cavity, which is the microwave, so I can place all the sensors in the microwave. And with the help of the spectrum analyzer, see if we could essentially use very low. What I'm getting at is there's possibility for an amplification factor if we could interact with the microwaves in the 0 point field and take advantage of the denser microwave fields and the amplification of resonance. And of course, asymmetrical regauging and all that. But we step it up to the microwaves, and it seems like I don't see a lot of people experimenting with all of this stuff, but into the microwave bands. And there's differences, and I think there's an opportunity there because if this could work in any way, it wouldn't be that difficult to use the potential of the ambient to drive the magnetron and use the microwave as the energy. You know what I'm saying? Maybe you don't. Maybe I don't even know what I'm saying at this point, but it's all part of the experimentation and learning process. So that's what I want to do. So I guess I'm going to go out there and clean it up. I'll be about 5-10 minutes, and I'm going to bring this microwave in here on the bench table here. Take a look at it, give it a good cleaning, and potentially start gutting it out. I'm going to remove the capacitor, I'm going to remove the microwave transformer, I'm going to cut the heater, I'm going to where the high voltage output goes to feed the microwave magnetron. I'm going to set up wires that go out of that so I could feed it with electrostatic. And you already got a resonant cavity, that's the microwave, it's oven part itself, and you've got plenty of shielding. So before anybody freaks out, this is relatively safe. And very, very zero currents, so, well, next to zero currents. So I'd like to have a significant amount, but, even a few watts of microwave isn't going to hurt you. And, well, it's not any worse than a Wi-Fi router is what I'm getting at. But if it's tuned correctly, that could be a trigger, at microwave. And much more refined, and we're not splattering with the RF spectrum and traditional. Like I said, microwave is very confined and focused, and basically you can take a piece of paper and it'll block half the radiation. So it's really weird. It's dancing away, but doesn't have much penetrative power. But if you've got a resonant cavity, the energy is very hot, so to speak. So that's what I want to do. I'm just going to motivate myself and get that microwave in here. And that's what I'm going to tinker with for the next few days and see if I can learn anything. And if all of a sudden I have a suntan, folks, you'll know why. That's just a joke. That's just a joke. That'd be more with X-rays. We're not interested in generating X-rays at this point, which makes the microwave a lot safer in that regard. People who drive electrostatic with the X-ray tubes, this is basically a magnitude below. It's high RF, but not ionizing radiation. So let's see what people are saying here. Yeah, just reading the comments here. Yeah, I was basically operating out of my kitchen, which was very inconvenient, but at the time, you got what you got, you use what you can, and I don't know how to say this. Well, I know how to say this, but it's just It's actually a sad story, and I don't want to get into the details on here too much, but my roommate got very sick and he's at the hospital right now. And it might be a while before he comes out, and he may not come out. And probably more towards he's not coming out. So, with that aspect, I was basically asked to, carefully put his stuff away and organize everything and send him everything he could use at the hospital. The rest is in storage because, there's no sense in staying confined, I guess, in a little spot when there's nobody here, and it might be for months and months and maybe never. So we're taking it day by day. You know, if he does get better, um, at the end of the day, right, always welcome. But there's also the reality, without getting too much into the details here, the medical situation. So it's been difficult for that. I don't do it basically out of fun. It's a unforeseen circumstance, and it just happened. So now, I have a little bit more room. So I was able to dedicate a room for the lab, which is better in a way because, when you, let's say, anything from deliveries to services, whatever, you open the front door and people who don't know what's going on, they see. I had a plumber one good time, looking at me, and he got a little freaky, and he said, if you're building a bomb, don't tell me. And it's like, why do you even say that? But it's just the mindset of people. If they don't know what it is and they see pipes and coils and, oh my goodness, the worst comes to mind, right? So I'm actually trying to make the world a better place. But if the people don't know that, it might look a little weird if especially they have no background in what it is I'm actually doing, right? Somebody can misintercept even a potato clock, unfortunately, these days. So there's a little bit of dumb in the world, I realize that, and you got to accommodate for it, folks, especially if you don't know who's always going to show up for what. So at least this puts a separator, it's close the door when I'm done, and no one has business in here unless I want to share it, right? In the proper context, such as YouTube with the explanations and everything behind it all. It's not just someone being a mad scientist. So I got to get closer here to read the stuff, so that's why. Yeah, thanks everyone again for watching, and yeah, like I said, there was like no easy way to actually explain, what's going on, but I'm sure you folks can just put the pieces together from this point on, and it's life, I guess. It's not easy, and everyone has issues and ups and downs. It seems like a win, but the fact that this is my friend and that I care for him, um, I actually see it as a loss. So it is what it is, you know. I gotta keep going the best I can, and that's what we will do. So with that said, I will be right back. I gotta find that microwave and clean it out a little bit. Not killing the stream already. If you're all wondering there, maybe I should actually write it down. Someone comes in. Be right back. Getting parts. There we go. So if people wonder why there's nothing, they'll see it on the chat. Be right back. Don't go anywhere. Oh, sorry about the wait. This thing was full of leaves. It's practically snowing out there. And just to think, a few days ago it was 70. So I'm going to try and clean this up a bit. Hello everyone, I'm back. Oof. So I do have some spray. Oh, the thing is, I was saying, I'm repeating myself, I know, but now that I'm all organized, I cannot find anything. When everything was all a mess in one bin, I had no problems. Now, I mean, everything is even labeled, and it just confuses me more than anything. Oh, where is the cleaning supplies? I know I put it somewhere, folks. Here. Ah, found it. Ah, okay, dokie. Yes, hello everyone. Just reading up on the comments here in case someone asks me questions. Try not to be rude. So now, don't know who had this, so let's disinfect. I don't even want to open it up. I'm gonna have to. It looks brand new. Be good for my experiment. Gonna be gutting most of it though. All in keeping is the tune cavity, in other words, the microwave itself, and the magnetron. Yeah, I'm not looking that good in here. That's what I figured. That's okay, it's going to be an experiment oven. See, my coils and cavities are going to go in there. That's going to connect to my hack RF, which can analyze up to 5 or 6 gigahertz. So any little peak at all, I will be aware if it's working. And if it's working, I'm looking for a cold reaction with certain frequencies, maybe, or high voltage DC electrostatic. An experiment with pulses and whatnot, and try and get the magnetron into a kind of resonant condition and see if it does like it does with vacuum tubes and give us radiant energy in the form of microwaves in this case. And if it does, we might be able to use the ambient to drive, with some modifications, the magnetron, and have resonant cavities in here at microwaves, do a little bit of Tesla. Now I'm not going to need this. I'm not going to need that. I'm gonna garbage that right now. Okay. So like I said, the nice thing is the cavity inside the microwave is already tuned. So if we can stick a bunch of tiny resin, the thing is the microwave is so high frequency that the equivalent of an LC circuit on microwave is about the size of the tip of my finger. So in this here, it would be the equivalent of the area of all of Tesla's lab when he had all of his coils running. But we can confine all that energy within this cavity here. And the signals bounce inside the cavity. Now the tuned resonators inside should potentially be able to amplify this circulating energy. That's my idea here that I like to experiment with. And if that indeed works, how to drive the magnetron with zero current and high voltages so that it gives us radiant energy in the form of microwaves to act as a trigger for the system. I don't know if it makes any sense. Just an idea to try. Microwave glass, yeah, I know, right? That's like the one thing that doesn't break when someone dumps the microwave out the window. Well, not out the window, but to the dump. It's not bad. It's dirty, but it could be worse. There's not like any rotten food in here or anything like that. It's mostly looks like cigarette smoke. Because I'll be mangling in here. I'm a little bit of a icky germs kind of guy, so still want to watch what I touch. So I wonder why nobody, or rarely, people experiment with Tesla concepts with the microwaves. I'm sure Tesla would have if he had access to those frequency ranges at the time, because it would have made his system much more efficient. And potentially we could have had something closer to what he envisioned. And I don't mean it in a bad way. Microwaves as RF is actually not that powerful, but if we can use it as a trigger to amplify the ambient with, it's pretty good without interfering with all of the RF spectrum like Tesla's original idea would have. So what I'm getting at is a modernized version of Tesla stuff, perhaps. It's still pretty dirty. Ay, ay, ay. So, let that soak in there a little bit. Sort of drench it. And get back to it in a few minutes. So, yeah, it's very interesting. The magnetron is it's very similar to a vacuum tube, and it does. I had a whole report on it. It's very interesting. I'll have to make a video just the whole details of it. It's as modern as a microwave is, it's a very primitive type of technology, very reminiscent of Tesla's stuff, because it's basically vacuum tube or vacuum tube like. It works in very similar ways. So what I'm getting at is for experimental purposes, it could really take a beating in relative to any other, like a transistor or a MOSFET, where we'd want to use it to generate RF. This lines up kind of like right in line with using it with magnetic amplifiers and that sort of thing, and you don't have to worry about digital systems and reverse voltages and that sort of thing. So that's what I mean. It opens up an avenue to experiment with those interactions I found with the modified Maxwell equations in a more practical way. Because as it hinted at, we need to go super high frequency, but our current semiconductors and the switching and all that, it's quite not there yet. And Tesla was in his ways, but it was very primitive and low frequency, and essentially interferes a broad range of the spectrum. So in today's world, um, playing with the low frequencies like Tesla would be doing is just, it can be done. It would interfere with everything in our technology society. But that's not so bad. You see, it's all confined and a lot safer than the X-rays, frankly. So yeah, something I want to experiment with. And as someone already said in the comments, I'm looking for interesting feedback mechanisms as well. So yeah, definitely the radiant energy should be able to excite as well. So I still have to figure out a feedback mechanism once I get all the resonators. It's pretty easy because you can just go online and find, like they call them Wi-Fi CAN antennas, or you basically use a little pipe, a copper pipe, and you build your own waveguides. And you could fit a whack of those in there, and we already have all the plans, and there's loads of, and Wi-Fi is like 2 point, it's very close, 2.4. The microwave is like 2.4, 2.5. It actually interferes with some of the old 2.4 Wi-Fi. So basically within the range of our Wi-Fi. And everybody uses Wi-Fi, so, I mean, go with the flow in certain ways, right? I mean, so I really think if we start experimenting, not just me, but more of us, with Tesla's traditional wave interactions with the microwave equipment, it could get very interesting and a lot easier to manage. When we're playing with like 20K and stuff, and we get into the high frequency, and then you have the sometimes we want it, sometimes it's undesirable, the skin effect and that sort of thing, and the high frequency is getting into everything it shouldn't. The microwaves, that's not a problem no more, and you have a much denser energy at microwave. So more confined and a lot denser, so a lot more potent energy. So to me, it's just like merge and bridge Tesla's work into the microwaves, and I think we're bound to find some interesting interactions. A lot easier to manage with as well. So that's nice. People are actually talking. Um, they're live streaming right now. Yeah, I don't want to just like interfere with what they're doing. I don't know them that well. They never asked me, so I don't like to bother people too much. I know some people tell me, go talk to this guy, go talk to that show, and maybe I should, because maybe that's what I'm doing wrong. And when I complain that I'm not getting enough following, right? But I don't want to interfere with their things, like Old Man Builds. He's doing the gravidifier, whatever. Yeah, that's what it is. Some pretty interesting stuff, but not quite in my field at this point. Um, I'd like to get into that direction eventually, but what am I supposed to comment on? Have you tried an asymmetrical capacitor? Yeah, this guy just read page one. But yeah, we all have our expertise, so I rather just, I guess, do my thing, and maybe one day, but I don't want to get too excited going on everyone's podcast because then you get all of the trap questions, I call them, right? And I don't want to make a fool of myself, really. I'm just a guy learning on my own, and if there's some interesting interaction, I'll share the results. I'm not the one trying to make rules here. Mm. Da-da-da. Not into gravity like assault people. Oh my goodness. I want to. It's just, resources. You have to split your resources in certain directions. I'd love to do it all. If I had another room, I had some movies on that actually, using basically the John Hutchison, some of the primitive interactions and how to enhance that. But that stuff is serious voltages and in some cases serious current. Um, Not something I really have access to here. But most definitely, especially the transmutation stuff, that's really interesting. But um, if I had a garage or something, maybe I'd like to do that. Like I have like good ideas on all the theory, but it's just and being alone too. At a certain point, you need a hand when you go with that stuff, and it can get dangerous too. You don't want something falling on your head when you're, your machine, whatever, and something. I've heard of that, and some stuff that's pretty heavy can end up, unintentionally going in your direction, and probably won't happen, but it could. Fly, yeah. Honestly, what I'd like, which they probably already know how to do, but they're keeping it secret, is teleportation. It just seems like the from a pure advantageous point of view without the science behind it and all of the dangers and all that, because we haven't figured that out yet, supposedly. But it would just make sense, right? If they're so worried about our climate and all that, why don't they introduce this stuff into the mainstream? End the story. Save the planet, right? And save yourselves. Then we wouldn't have to worry about buying gas if we could just teleport to where we need to go, you know? Just weird ideas, I guess. But then they'd probably find a way to exploit us for that, right? So then if we'd be able to teleport everywhere we want to go, they'd probably make us work 2 hours more a day because, hey, you don't have to drive an hour to work and an hour home no more, so you can be more productive and just suck it all out of you. It's just there's always somebody out there to exploit anything that could actually be good. So at the end of the day, you know what? Anti-gravity, yeah, and all that. Teleportation, but guess what? If we'd have it, they'd find a way to exploit us. Anyways. Yeah, all that teleportation, I don't doubt it at all. Especially, maybe that's what's scary. Even in the new Maxwell equations, it all hints at all that stuff, anti-gravity, teleportation, time travel, the bending of space-time, and all that stuff, and the mathematical framework behind it. So it's a little bit encouraging, but I don't think I'm going to have all the equipment overnight to test every theory personally, but there's some stuff which really made me think more about, high frequency seems to be key here. We're all on the right track with our resonance and amplification and all of that, and the scalar waves, and but because we're so limited in those 0 point interactions in such a short time, the only way to take advantage of that is to crank the frequency up. And RF behaves differently depending on what frequency you're in. Usually when we talk about RF, people think, oh, 20 megahertz, 60 megahertz. But no, let's go 6 gigs, And what about 60 gigahertz? That's tricky because then you're dealing with like little solder blobs. But if you want to go down to efficiency at 60 gigahertz, a tube like this might be able to provide 10 watts of energy, you know? At the micron scale, I need a factory of some sort to build that, but this gets into like anti-radar technology and all that, and the shieldings the government have. What those are, they absorb the radar energy, which all runs in the high gigahertz and gives you energy in return, right? So they're siphoning the energy of the radar. You can't create energy or destroy it, so they're just converting it back so the wave doesn't bounce back. So, of course, the advanced people already have all this tech, but it's to find a way to us do it and make it accessible to the mainstream, right? That's what matters, is making it all accessible to the mainstream. Yeah, that high voltage stuff I called it the quantum energy generator. If you want to look in some of my videos, and then the quantum energy generator version 2 was pretty successful, which led me to make the like this pipe-like device that I even had the meter in front of it. Input was 40 mA, and the output was like 7 watts. And that was pretty good. Um, Pretty complicated, but it all worked. Yeah, lots of interesting stuff you can do with microwaves, and I was thinking of that too with the John Hutchinson stuff. I didn't want to say it out loud there because I don't want to give him bad ideas, you know. But yeah, I was thinking of experimenting with the magnetrons for that sort of thing as well. and create Tesla coil equivalent, but as cavity resonators. So if they're resonant, they will put out their own amplified energy field, which will feed another one nearby. And if they could all fit in the microwave oven, the microwave oven itself is a resonant cavity, so you have all this bounce energy going on, and it's the feedback you want, right? So there's a really high potential there, literally, and easier to control and confine. So I know I'm repeating myself, but just open discussion, right? Just, and I'm getting pretty tired tonight. I was going to open this up there. I have a bit of work to do. I want to gut it out, take the microwave transformer, keep it for a spare part, capacitor as well, cut the cables, keep the magnetron right where it is. And I'm going to start feeding it with my own energy sources and put some probes in there and scan for some interactions with the SDR program with the computer. And if there's any interesting interactions, I will make videos and share my findings and hopefully encourage everyone else who can, who may even have more resources than I do, to carry on these experiments and elaborate on them and extend and modify and enhance and come up with your own discoveries. And with that said, how long has it been? Wow, an hour and 15 minutes. Not bad. I just wanted to say hello here, and I was just going to connect the computer. I was actually expecting a lot more problems because it's my luck when I move a computer from another room, usually nothing starts up, hardware doesn't detect. It was pretty smooth. Just a bit of a dumb blonde moment on my part. I couldn't get the screen to go because I hadn't plugged in the HDMI cable. Duh. Once I did that, everything came up fine. And with that, folks, again, thank you all for watching and supporting through interactions and sharing the channel. It really means a lot to me and motivates me to keep researching and coming up with concepts to test and interact with. And of course, it's the interaction as well, and there's the forum, typewrite.social. I'm always on there as well. If people have, more intensive stuff they want to talk about, sometimes YouTube, you have limits. So you could all go to the forums and talk in details. Sometimes it takes a moment for me to reply, but I usually do. And with that said, folks, I'm going to wrap it up, and I hope you guys all have a wonderful evening or whatever time it is out there where you're watching. And thank you all for your support, and have a great day, folks. Thank you very much. Just got to figure out how to end the stream here. I'm going to just say good night to everyone. And until next time, folks.